we're going to pick up and continue our synthetic division. And on these problems, we got to be a little more careful as we move forward to continue to make sure we have perfect descending order. 4, 3, 2, 1, none. So that part, we're good to go. And we are dividing by linear, so we can use synthetic division. So we're going to go ahead and see what happens. Perhaps we have a remainder this time. So we've got x plus 1. You set that equal to 0 and solve for x. Subtract 1 from both sides, and you get x equals -1. This is our first step every time with synthetic division. Give yourself a little half box right there. Then the 4x to the 4 plus 11x to the third plus 10x squared minus 5x minus 17. Bring that down so that I can take all my coefficients from it. So 4, 11, 10, -5, and -17. Just playing with the coefficients, don't have any variables to deal with. So now we roll through our algorithm, which is you take the first term, bring it down. First coefficient is 4, and you multiply by whatever's in the box that we solved and isolated x for. And here, 4 times -1 should give me a -4. And I add those coefficients, the 11 with the -4, I should get 7. And then I go ahead and repeat the process. So I take the 7, times it by -1, and that should give me -7. Then I add with my 10, and that should give me 3, and repeat. 3 times -1, bring the answer over here, it should be -3. Add that together to get a -8. And one last time, I take the -8 and multiply it over here to the -1, bring the answer over here as a +8, which means when I add here, I get a -9. Now, that is my remainder. This was not a 0 this time. First example where we don't have it be factor. The x plus 1 is not a factor. So this is my actual remainder. And here's what you do with that. The same thinking and reasoning goes through in the previous examples where we had x to the 4th, and we're dividing by a linear, so I should be going to an x to the 3rd result polynomial, which means you just take a degree, drop a degree, and I'm going to put my variable starting with the highest exponent of 3 at the front, and then I just fill in my terms. So there's going to be plus 7x to the 2nd, plus 3x to the 1, and then minus 8x to the none, and then we've got a remainder. Well, the remainder is, I rewrite it this way. It says to write it as a quotient plus your remainder divided by your original function. This would be your b of x function, if you will. And so we put this over, so plus -9 over x plus 1. So my answer, the result of division, is 4x to the 3rd plus 7x squared plus 3x minus 8 plus fraction bar -9 over x plus 1. That should be my result of division. And if I really cared, I could try to multiply that all by x plus 1. And if I multiplied it by x plus 1, it should produce the original polynomial that I started with.